The broadcast is now starting. All attendees are in listen-only mode.
Hello everybody, my name is Florin and I will present you today a new module, the new solid probe module of SolidCAM, and today we have not only the solid probe, we have also tool presetter options with this new module. With solid probe, we have capabilities today to define a home on the machine and also to verify the part in process. Of course, this is not a CMM machine. It's not a very precise measurement, but we still depend on the machine backlash and axis deviations, but we can get a very close picture about the status of a machined part. And it's this measurement option, it's used very oftenly by the users. So let's start to see how we define a probe operation and what options do we have inside. When we add a new probe operation, the first thing that we need to select is what kind of measurement I will do now. So, and we have several. We have one touch point in each axis, in X, Y, and Z. We have angle measurement in X, Y, and Z. Center for both pocket and pocket with boss. Center and also the dimension of this boss or pocket. The same for a cylinder, hole and hole with boss. We can find the center and we can measure the diameter. Measurement of an external or internal arc and finding a corner if it's external or internal. We are going to start one touch point. Select the technology. Here in the action we have home position or measurement. We start with home position and geometry definition. We need to define a geometry. For one touch point we define a geometry as a drill, 1 point. We can touch any wall, straight wall. For example, I want to measure here to touch with the probe this wall and to define the home where is defined in coordinate system manager. I define in the middle of the part. So if I will touch here this wall, the probe cycle will tell to the controller your machine is, your home is at a specific distance that we measure from this part. So I define a point, and the next step will be a tool selection. As in other operations in SolidCAM, the same user interface, select geometry, select tool level technologies. For the tool, we add a new tool in tool table, the probe. I will select the probe with a ball diameter 6 millimeter. We have the clearance level as in any other job and technologies. Right after selection, I already see the toolpath. The probe will come to the specific point, to the defined point, the geometry, with distance, approach distance, and with the mouse wheel I can define the level where I want to touch this part on Z level. And another option that we have here is the reverse movement, if we need it. If I touch, for example, this wall here, I need to select the reverse movement. Also, in this part, if I want to measure to touch the wall from inside, I can easily use the same geometry, use the reverse, and give an offset. Now the process will measure this wall, the probe will touch this wall from the inside. Rotation angle, I will define another geometry here on this wall to see how we find the angle. Save and calculate, and we can also make simulation, solid verify, machine simulation, all included. Let's save it and we select another geometry. On this wall or edge. In technology, I already see the toolpath updated to the new geometry. But now I want this movement to be perpendicular to the surface. There are several cycles on different device probe, different manufacturer has different cycles. So for Renishaw, for example, we have option to rotate the movement. So I can rotate the movement to be perpendicular to the surface, but if I don't know the angle, I can read it from the part. Just touch the surface and we have the vector. Angle is measured automatically, and we have here 45 degrees. What I just need to do is to correct the Z level where I want to touch. So I have the process for measuring this wall on angle. Save and calculate. Let's see. Here I will get a cycle for an angle movement. This is we have the protected move cycle 9810 for inspection plus. Go to the specific point Z10. Also always with a protected movement, go to Z-R4, the level that I defined to touch the part with a feed, and this is the measuring cycle 9821. Measure on angle 45 degrees on distance from the wall 12 millimeters and define the home number 1. Retract to clearance also with protected move. Now if I'm going to the previous operation and generate the G-code, you see we have different cycle, the same protected movements, and the cycle is 9811. Touch the wall in on X minus 114 here on this wall and define the home number 1 and also retract. So the G-code, output of G-code is changed based on the cycle that we select. We select a straight movement or angle movement. We have different cycles that we will use. Okay, so this is for a single point in X. The same technology is used also for Y. A one-touch movement in Y-axis. Let's select, excuse me, my voice is, yes. So I will touch this wall from in Y-axis with the same tool. In technology, preview, I already see the movement, the toolpath. Set the level. Also, always we can see the updated toolpath when we change something in interface. With each value from this interface, it can be changed with the mouse wheel. Also, it's also working offset and rotation angle, the same as in X-axis. Here the G-code will be the same cycle, 9811 for inspection plus, but touching Y on this point, movement, we have a Y movement, and define the home number 1. For Z, measurement, single point in Z, we can touch any level that we want. Let's take this level with the same tool. And here in technology, you see, we don't have any angle or rotation to do. It can be done only in tool axis. Now, the level, I can go manually to the selected level or to copy it from the part. Touch the level and we have -20. This is about single point measurement cycles. Angle on X first. I will take this geometry. I want to measure this surface angle with the same tool. And in technology, I already see the movement. What we have here also, we have offset. We can go close or far away from the part, depend on if we have remain as stock material. We didn't finish the part. Maybe I work first only rough and I want to measure the part after a rough process. So if I have some material, we can use the offset. Move start and end point. The probe will touch the surface on the edge. If I don't want to do this, I can short the toolpath, move the start point and move the end point to touch not on the edge. So this is the angle on X. In the same is working. We have also the reverse. If I want to measure this surface here, I need to use the reverse. Now for this surface, I can measure this surface also with angle Y. Angle in Y-axis, the toolpath is updated right away. And let's see the G code. We have a cycle 9843, touch the part in Y, have a Y movement, and the distance between two touch points is 13.617, and the surface is in 45 degrees. If the measurement cycle will find, yes, I'm sending this angle from the part. I know that the part has this surface on 45 degrees, but if on the machine is not 45 degrees, we have a deviation, 1, 2, 3 degrees, with this deviation, the home will be rotated. Rotate the home with G68 function, with variable 139, where is saved deviation of the measurement. Now, angle in z-axis, it's a little bit different because we can measure an angle in z in plane yz or zx axis. So I will define from start, not drill, sorry, need to define angle z and define the geometry. I will define from start two geometries, point to point, and another one in YZ plane from this point, now delete, from here to here, and another chain from this point to this point. I have two geometries. Now select the tool, and in technology, first I will measure in ZX plane. Okay, the clearance. The geometry is the second for ZX. I think, not this, yes. No, we have, I will define a new geometry. Something it's cut wrong from the first definition. Let's take first this, and also an edge can be selected, and this edge. On technology, on first I want only this. Okay, ZX. Now the start point and move point, I can play with them, and also I have a side shift. For the second technology, if I will add, I will use the second chain and select YZ. Also we can see with the side shift bring the probe on the surface, and also play with start and end point. So what we see here, that in one operation we can use several technologies, measure in ZX plane or measure in YZ plane. Let's put it on the surface. The side shift is okay. 3 millimeters from the edge. Now it's okay. Save and calculate. And if I make the G code, I will see first I measure with the cycle 9817 in X, and the second cycle, measurement cycle, is 9818, angle measure in Y. And this is about angle probe cycles. Now we are going to boss, pocket, and pocket with boss. For this kind of cycles, we define a closed geometry. With the tool. And we already have the toolpath for X measurement. I can change it to Y, and I can work also on both axes. There are different kind of controllers with different cycles. In Heidenhain, for example, we have cycle to measure with 4 points, also in X and Y together in one cycle. For Renishaw Inspection Plus cycles, they have separate cycles for X and for Y. So if we need two measurements in the same operation, we define the first one in X, and we will add a technology, and for this technology I will select Y. So we have possibilities for to support all kind of cycles. Even if they are limited by controller, we can still output a measurement in two axes in one job. Now this is the boss. Now if I will select pocket, I can select again internal geometry or use the external with an offset. I will use an offset 5 millimeters for this cycle and also for Y measurement in Y cycle, the same offset. We have a pocket measurement. The process will find the center, and also we will get the dimension of the distance between two touch points, the x-axis and Y. Now, the difference between home definition and measurement, that in the home definition we'll define the home, and if I want to make a measurement, we have some extra additional options to define the tolerance. So I will search for the center between those two touch points, and I can give a tolerance. The center can be in x-axis meaning maximum tolerance and y-axis meaning maximum tolerance. I also can give for the dimension, the distance between the two touch points, a tolerance, and the cycle, different cycle with different options. One cycle can show you on the screen on machine as the Heidenhain does. You will get a report on the screen. Other cycles for other probe devices, they will save the results of the measurement in a file, in a controller or a flash card. For example, the Fanuc can save the results, measurement results, on a flash card, or he can transmit online through the serial port RS-232 directly to the computer. There are several options. The user can select them and how he wants to get the results. And not only the tolerance, but the cycles have they have also different variables, customized variables, percent feedback, tool offset number. If this pocket, we check this pocket after a milling operation, and we see the cycle will measure and see that dimension is smaller. If it's smaller, we can select a tool to change the offset. I said, okay, for this offset, for this tool number, change the offset with the deviation that you find in measurement. So you can activate this option, tool offset number, what number, and he will change the offset depend on the deviation that you find after the measuring cycle. Print data, will print data, he will save it in the file. There are specific parameters defined to support specific cycles. And this is the pocket. Now we are going to pocket with boss. Pocket with boss will give us this kind of a movement. Let's go up with the touch point. The probe will always go to clearance level, go down, touch, back to the clearance level, and to the next point, down and touch. He will always go to the clearance level because take example of this entity here. If I want to measure inside, let's select another geometry very fast. I will select and technology. Yes, we can see here very clear that we control the entrance, the movement with approach retract not to have a collision, and dip level, the Z level, offset also. We have all those dimensions. It gives us the total control about the probe movements in a measurement cycle. Shift from center, I can move it in y-axis, yes, parallel, a shift parallel to X. Save and calculate. The same we have for cylinder. It's working in the same with the same technology, only that here we have several additional options. Let's select the external geometry for this cylinder and the tool. Here we can define, when we measure a cylinder or a circle, we can define the number of touch points. So the minimum, we have 3 points, but the standard is 4 points. Define the Z level and the distance, the approach distance, not to have any collision with other entities in the part. Offset is standard in all solid probe operation. And move start point. Move start point, that means I can rotate this measurement cycle around the center, because I can have here on the part a groove, maybe something, a hole, something that it's not giving me the possibility to touch. So this one of the touch points I need to move, use the move start point, and the entire cycle is rotated. This for cylinder, and if we use the same geometry for the hole, just use the offset and we can measure the internal diameter. All options available here also. And the same as in Pocket, we have a hole with boss. This is the better example. I will select the internal geometry here. And for the levels, go up 4 points or 3 points, depend on what cycle we choose. Reduce the distance, and we have a hole with both measurement cycle. The probe will go always to the clearance. Now, let's see the difference in the G-code. Here with 3 points we use cycle 9823, and the touch points are in A, B, and C, defined by angle, diameter 56, and Z level -5. The retract distance, retract approach is -10 because it's inside. This is what the cycle needs. The approach distance from outside will be positive. If I will select 4 points, save, and G-code, we'll get a different cycle, 9814, with the same dimensions, diameter 56 and Z level. Depend on which cycle you want to use. You select different options here in the interface. Next, technology. External and internal arc works in the same way as the cylinder, but only from center to outside. Its external arc is working like as a cylinder option. Let's take this geometry here, this edge. With the same tool, and we already see the toolpath. We just select the Z level. Now always the probe will start measurement from the center. This is for Renishow Inspection Plus. If you are trying to do with Heidenhain controller, you will see a different movement, a different type of cycle, measurement cycle. And we support this in toolpath preview and also in simulation. Depend on which controller we define in machine ID and which probe we select, which probe device, we will see a different behavior, a different toolpath. For internal arc, the same with, let's define with an offset, -5. And also can change number of points, 3, 4. The standard cycles work with 3 or 4 points, but a customized cycle can be written. What is a cycle? It's a macro programming controller. If you know the macro language and you can write for yourself a cycle with 5 or 6 measurement points that you want to do it more precise, you can do it. Just tell us the number of the cycle and we will output this spatial cycle that you wrote. The last option in technologies, we have the corner, external and internal corner. For this we select a geometry, a chain with two edge. One is the first, this is the second. Tool, as always, we need to select, and we already see one touch in x-axis and one touch in y-axis. But we have also cycles that can measure and find the corner with 2 touch points in each axis, in each direction. So just check this checkbox here and define the second position in x, second position in y. Very simple, very fast, preview updated. This cycle can measure also and find the deviations. That's mean because he touched the surface in 2 points, he can measure the angle, and the cycle with 2 touch points in each axis, it's more precise, and you also can get the angle deviation as a result. The internal corner is the same, but let's select the geometry, internal. I will select this edge and curve plus close corners. I will close the corner. First we get only 2 touch points, and if we want to use an advanced cycle, use the second point. This is about angle, a corner, finding the corner and measuring the deviation of the surface. Those are the technologies that we use for now in 3-axis machines. We have in development now in a very advanced stage probe for 5-axis in Dexial. We can work with, we will work with probe in positions. We work with milling operations. Very useful for castings, and when you work on a part with more than one coordinate system. I hope that in the next service packs of this version of SolidCAM 2014, this new option of solid probe, the new level, it's the next level on the 5-axis, using 5-axis in Dexial, will be implemented. And I hope you enjoy, and if you have any question, I can answer now. Let's see here on questions. No, nobody have any question. So, thank you for joining us today, and see you on the next webinars. Thank you, everybody. Bye-bye.